Right, this time I'm going to focus on some bit related instructions. So there are these bit scan, bit test, and bit count instructions. So we'll start with this bit scan forward, go through bit scan reverse, and then these bit test ones here. And then we'll go on to things like leading zero count, trailing zero count, and population count. So starting with a BSF, we'll just go and create some tests for this. So we'll call this bits.asm. So we've got BSF, and it's got 3 forms that are all valid in 64-bit mode. So we've got 16-bit, 32-bit, and 64-bit, and they are all operand encoding RM. So we'll just do 16-bit first, so we'll do CX with, let's say, the registers first, so we'll do maybe just DX. Then we've got ECX with EDX, and then RCX with RDX. So that covers register. Now we need register memory. So we'll just take these and change these into RDX here. So that should cover all of the forms for bit scan forward. And since these ones are so simple, I may as well just cover BSR as well. So BSR is the same thing, it's just a different opcode. Something like BT has immediate forms as well, so I'll do those separately. So we'll focus on BSF and BSR first. So we'll do NASM, CodeGen, x86, test data, bits. We'll create a listing for this. Bits.lst. Okay, and then we'll go to the encoder. So maybe I'll just put these up at the top here. We've got BSF and BSR. Let's go to the encoder test, and I'll create another test group here. So this is going to be bits.lst. So we need op BSF. So we've got word, and we're doing CX, DX, NANA. Then we've got D word and Q word, and then we've got the same stuff, but with DX being a memory access. Then we've got the same things again, but this time it's BSR. Okay, so let's run these tests. Okay, no forms, so let's go to the forms. We'll put these up here, so we've got BSF. So we're going to match on, let's see, where is it? It's bit scan forward is, so there's an opcode map, but they've all got the same opcode, so I can just use a single form for these. Okay, so we'll do width is word, D word, or Q word. Op n for these is op n rm. Op1 can be a register, op2 can be reg or memory. There's a map of the secondary map, and then the opcode is BC for this one. So we've got BC, and then BSR is the same thing, but instead of BC, we've got BD. So now let's run those tests again. Okay, so that all passes. So now moving on to the bit test ones, these are all the same as each other, these 4. But they have additional 8-bit immediate forms as well. So we'll do a copy of, and these ones actually are MR encoding instead of RM. So we'll just make a copy of the, let's say BSR here. Okay, so this is going to be BT. But because the encoding is the other way around, we'll just take these and swap them. So that covers these forms here. Then we just need a copy of the two, but changing the second operand into an immediate that fits within 8 bits. So we'll just take this. And then for each of these, we'll do OX7F, let's say. And then these ones down here are going to need to be word, dword, and qword. Okay, so I think that's it for that one. This one BT can be, we'll change this to BTC. Then we've got BTR and BTS. Okay, so let's just check NASM. That's all okay. So now I just need to let's go to the encoder test. So we'll copy this one. This is now going to be BT. We're going to switch the operands around. And then we're just going to make a copy of these and change the second operand to an 8-bit immediate. So this is 0x7F. And then we'll make a copy for each of the other mnemonics. So we've got BTC. Then we've got BTR and then S. Okay, so let's just change these ones to R. And then these ones become S. Okay, then we need the mnemonics. So in here we've got BT, BTC, BTR, and BTS, and then we'll go to the forms and just create these forms as well. So the initial form for BT can basically be the same as this, but we're changing the operand encoding to MR, which means that op1 needs to accept memory and op2 is only register. Then for BT, we've still got the secondary opcode map, but the opcode itself is A3. So we've got A3 here. Then for the immediate version, we'll create another form matcher. So we've got word, dword, and qword still. But instead of matching reg, we're going to match im8. We've still got the secondary opcode map. We've got BA for the opcode, and then these ones have an opcode extension of 4. Opcode extension 4. Okay, so that's BT. Then we got to do 3 more. So we've got BTC, we've got BTS, and BTR. Actually, I think it was R then S is the order I did it in. Yep. Okay, so let's just see if these tests fail properly. Yep, they do. Okay, so BTC is going to be BB and... Okay, so the ones with the opcode extension don't change the opcode because the extension itself is the thing that's changing. But the opcode for the other one is BB here. And the opcode extension is 7. Then for the R version, we've got B3. And we've got an opcode extension of 6. Then for BTS, we've got AB, and the opcode extension is 5. Okay, that's all fine. So now we just need the bit counting instructions. So we'll start with a leading 0 count. So this only has 16, 32, and 64-bit. They're all RM encoded. And these ones actually have a mandatory prefix, by the looks of it, of F3 here. So we have the secondary opcode map escape here, and then the opcode, but this one here, this F3, is a mandatory prefix that has to come before the map, which I don't actually have built into forms yet. So I think before I do any of these counting ones, I'll just add that to the forms. So we'll go and find the form type. What we need here before map is going to be prefix. So this is going to be the prefix type. And we'll put this up here somewhere. Maybe we'll just put it here. We'll say type prefix is a byte. And this will just be... yeah, I suppose I'll just make it the actual byte. So we'll just say const prefix none can just be 0x00, let's say. Then we've got F3, so this will literally just be F3 here. And there are more prefixes if we go up. I wonder if it's worth putting them in now or just as we encounter them, but maybe we'll just go up and have a look at them. So instruction prefixes here, we can see here's F2. Here is F3, for example. There's F2, there's F0, and things like that. I may just add these as I actually need them, though. So we'll just ignore that for now and just go with the prefix F3 right now. I do know that another mandatory prefix, for example, would be, if we go down to interpreting the instruction reference pages, there is reference to these prefixes for VEX encoded instructions. This is the opcode map. These are like some mandatory prefixes. So 66, F2, and F3. I think for EVEX it's the same. So maybe we'll just add 66, F2, and F3 while we're looking at this. So we've got F2 and 66. I think that will do for now. Okay, so let's get back to LZ count, leading zero count. And in the encoder, before we output a map, we'll need to do a switch on the prefix as well. So we'll say switch on prefix. In the case that it's prefix, actually, we don't need to do a switch on this, I don't think. Prefix is always 1 byte, as far as I can tell, in the case of like mandatory prefixes. So we can just say that if the form prefix does not equal prefix default, then we'll just add it on. So we'll say append e.code, the actual prefix, because we've encoded the actual bytes here, so we can just output it directly in the legacy encoding case at least. This will change a bit once we get to VEX and EVEX encodings. Okay, so let's just do test. I think that okay, undefined prefix default. Oh, prefix none. Okay, we'll just change that to prefix none. We'll just do go test, make sure it is running. Cannot use form prefix as bytes. Yep. Okay, so we've got to change this into an actual byte. Okay, right, so now we've got prefixes. I can start creating some tests for these. So these ones are RM, the same as the scan instructions. So we'll just take the test cases for the scan instruction and put them down here. This is going to be LZCNT now. So if I do NASM, that should all be okay. Then we need to go to the encoder test. We'll take the bit scan forward tests here and add them to the end. So bit scan forward is now going to be leading 0 count. Okay, so op BT, we'll do LZCNT, we're going to have TZ as well for trailing 0, and we're going to have pop for population. So let's go and just create some forms for this, or at least some empty tables. So we've got LZCNT, that can be an empty table there. We've got TZ, and we're going to have pop as well. Okay, so let's just run these tests. Okay, could not match instruction forms. So LZ count is basically going to be the same as BSF here. With the big difference being that it now has a prefix, which I think was F3. And then the opcode itself is BD, so we'll just change this from BC to BD and run the test again. So here, oh, okay. Yeah, so here we've got rex W, which is okay. So the prefix has to come before the rex as well. So let's go to encoder, form.prefix. So I just need to move this up a bit more to before the rex stuff here. And then this one, okay, so the operand size override is coming before the prefix here. So where is my operand size override? Operand size override is here. So I think I'll just have to move this out. So we'll say if the width is equal to word, then we'll do the operand size override. Then we've got some rex stuff here. Okay, let's try this. Okay, that's all okay now. So next we'll move on to TZ count, or trailing 0 count. Here it is. Okay, so this is exactly the same thing, but the opcode is changing to BC. So let's just go to the bits ASM. We'll make a copy of these tests here. These can be TZ count. Regenerate the listing. Copy LZ count here and change it to TZ. Okay, we get no forms. Then we can basically just take this and put it in here, but change this to C instead. So that passes. And then the final bit count instruction that I want to do is pop count. So it's going to count the number of bits set to 1 population count. So again, exactly the same thing, but the opcode is now B8 instead. So we'll go to bits ASM, copy TZ count, call it pop count, and then copy this and change this to B8, I think it was. Okay, that's all working. So that was a bit scan, bit test, and bit count instructions.